Okay, so solving rational equations. So we've done a bunch of stuff with rationals so far, right? We have simplified rational expressions. And when you do that, you factor the numerator and the denominator. We have looked at non-permissible values. And when you do that from the factored form of the denominator, right? We multiplied and divided rational expressions. And when you multiply and divide, you factor the numerator and the denominator. Right? Then you state restrictions and away you go. We did adding and subtracting. When you add and subtract, you factor the denominator only. Right? And then you do your adding and subtracting bit, and then you simplify at the end. And then perhaps you do factoring of the numerator. And solving is more similar to adding and subtracting in a sense. Because in a sense, we really are adding and subtracting, but we're going to add one little step in there, which is this time we're solving, we're going to come up with a value for x that makes something true. And in order to do that, we're going to get rid of the denominator. So let's start off with something that you'll never see on a quiz or test. It's too easy, but it is a rational equation. So what makes an equation an equation? What do you have to have? It's got to be equal to something, right? There's an equal sign. And you will see the word solve, right? Solve means you're looking for a solution, right? The values that make things true, as opposed to seeing the word simplify. Simplify can be used when you are simplifying. When you are multiplying and dividing, the instructions will be simplified. When you're adding and subtracting, the instructions will be simplified. Right? And all you're going to do is come up with, when you're simplifying, is come up with a simplified expression, but it's still an expression, right? It's not equal to anything, and you can't find a value of x that makes it true. This, you can find a value of x that makes this true. Right? There is one value of x, which when you plug it in there, makes this a true sentence, right? So we can solve. We can find the value of x that makes this true. Now we're going to run through a few steps in solving rational equations, right? So number one, step one is to factor the denominator. Now in this case, we don't need to do that, right? They're already in a factored form, or there's nothing to factor. Step two is we're going to state the restrictions. Now here there are no restrictions because there is no variable in the denominator. Right? So to have restrictions, we need a variable in the denominator such that some value of that variable will make the denominator 0. Can't do that, so that's a restriction, right? You're saying, okay, I can't make the denominator 0. We're then going to, just like adding and subtracting, so far that could be the first couple steps of adding and subtracting, is we're going to figure out what the LCD is. Okay, what's the lowest common denominator? But instead of adding and subtracting, we're going to multiply each term by the lowest common denominator. Okay, so in this case, factor it, no, nothing to factor, no restrictions. Lowest common denominator is 10. So I'm going to take 10 and multiply every term. Now in this case, there's only 2 terms. And I like to write the 10 over 1, because here's my objective. The objective is that once we've multiplied every term by the lowest common denominator, we could do some canceling. So 5 goes into 5 once and into 10 twice. And 2 goes into 2 once and into 10 5 times. That what I'm aiming for is that I have 1s in the denominator, right? That's it. Every denominator must now be a 1. And then what does that give us? Well, in this case, it gives us a linear equation. 2 times 3x is 6x is equal to 5. So x is 5 divided by 6. And we have now solved this equation. If you go 3 times 5 over 6, you're going to get 5 over 2 divided by 5, or times 1/5, gives you 1/2. Right? I mean, you can do that on your calculator. You can just go 3 times 5 over x and then divide it by 5, and you should get 0.5. Okay, now that is a rational equation. It's not the kind that we're mostly going to solve, right? So what we're going to do is just amp it up. We're just going to do a number of other examples, just showing you in each case, okay, what's different about this one? You know, what do you have to do here? Follow all the steps. Remember what to watch out for. Okay, and that's basically what we're aiming to do. The thing you got to watch out for, right, is that multiplying and dividing, well, simplifying, multiplying and dividing, adding and subtracting and solving are all very similar, but there are some subtle differences, right? So you have to know, well, when I'm adding and subtracting, this is what I want to do, right? I need to get the LCD. I need to multiply. I need to get every term to have that LCD, right? We write down the large denominator bar, and we put the LCD on the bottom there, and we get an expression that has that lowest common denominator. Here, we're not aiming for that. We're trying to get rid of the denominators and get an expression that can be solved. All right, next up. 5 over x minus 1 is equal to negative 2 over x plus 2. Okay, step 1, factor. Is there anything to factor? No. Okay. So 1, factor. Denominator, right? Not the numerator. You're not going to touch the numerator. Okay, just like adding and subtracting, you're not going to touch the numerator. You don't want to factor it. Multiply and divide, you want to factor numerator and denominator, right? This is a distinction you need to make. So when you're sitting there getting one of these problems, be it on a quiz, a test, or just in the normal course of solving stuff next year, you get one of these problems that you know that, oh yeah, okay, I'm not going to factor the numerator in this case, right? So it's just practice, right? You've got to practice so that you know what to do in any particular case. So factor denom, check. 2, restrictions. What are the restrictions? Okay, so x cannot equal 1 or negative 2. Step 3, what's the LCD? X minus 1 and x plus 2. Okay, next step. We are now going to multiply every term. In this case, there's only 2 terms, right? We're going to multiply every term by x minus 1 times x plus 2. So x minus 1 times x plus 2, and I'm going to put it over 1. I like that because then I have a 1 sitting in the denominator, times 5 over x minus 1 equals negative 2 over x plus 2 times x minus 1 x plus 2 over 1. Okay, so remember, what are we aiming for? We want to have every denominator be a 1. So this is already a 1. I'm not doing anything, right? So I can take the x minus 1 and cancel it, and it becomes a 1, right? X minus 1 goes into itself once and into x minus 1. And the same deal with the x plus 2s. And now I look at all 4 denominators. They're all 1s. So now we're good to go, right? There is no more denominator, right? Denominator is 1. So now I can just simplify. So I have 5 times x plus 2 is equal to negative 2 times x minus 1. Now what we do is we expand that and we collect the terms and we put x's on one side and blah, 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 right? So do some math. Right? I mean, at this point, we're into familiar territory. It's just solving a straight equation. Okay, good. So 5x plus 10, and I'm going to add 2x to both sides, and I'm going to subtract 10, and end up with negative 8 over 7. Now, George Pauly in his 4-step problem solving was understand what are we doing? We're solving an equation. Plan, how am I going to do that? I'm going to factor the denominator, state the restrictions, multiply everything by the denominator, so that's the do, and then look back. And the look back part of it is, since this is an equation, is saying, I have a solution, I need to check it against the restrictions. Right? Because sometimes the act of solving introduces extraneous solutions, right? And it makes one of your solutions equal to a restriction, and then you need to reject that and say, well, that's not going to work, right? because it's not. It is a solution to this, but it's not a solution to the original, since you'd end up with a 0 and blah, 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 right? Okay, any questions? Do another one. 3 over 2x minus 2x over x plus 1 is equal to -2. So in this case, now we've got 3 terms, right? Now we're dealing with 3 terms. All right, same deal. I'm just going to give this term a denominator, right? It's a -2, so I'm going to write it as -2 over 1. That way all my terms have denominators, just makes life a little bit easier, I think. Step 1, factor. What are we going to say about factoring? Factor denom. Don't need to do it, right? It's already done. Step 2, restrictions. What are the restrictions? X cannot be 0 or -1. Okay, so when you're doing restrictions, you have to have exactly the right number. You can't add any extra ones, and you can't leave any out. Right? And restrictions are just what value will make the denominator 0. Step 3, what's the LCD? Yeah, we got a 2x, and we got an x plus 1. An LCD usually is just what? Once it's in factored form, we should say, okay, I need one of those, and I need one of those, and that's just one. So I don't need one. Okay, and then don't repeat anything. If you see an x plus 1 here and you see an x plus 1 over there, you don't write down, I need an x plus 1 and then another one, right? Okay, step 3 is multiply. Well, 3 is the LCD, so then multiply everything by the LCD. Now, there's the way I've been doing it, so I'm going to do this a couple of different ways, right? So we'll just do it the way we've been doing it, and then I'm going to show you a shortcut method that you may choose to use, okay, which is perfectly valid and leads to the same result. So we're going to multiply everything by 2x times x plus 1 over 1. Multiply that by 3 over 2x. Minus, and it doesn't really matter what order you do this in. 2x times x plus 1 over 1 times 2x over x plus 1 is equal to -2 over 1 times 2x times x plus 1 over 1. All right, so we found the LCD. The idea now is just down with denominators, right? We don't like denominators. They don't help us out. We want to get rid of them. So we multiply everything by the lowest common denominator. That way anything that's in the denominator is going to go into this, right? Because it's common. Okay, that goes into that. This takes out this, and these guys are 1. So after I've done all my canceling, all I should have in the denominator is 1. 1, 1, 1, 1, 1, right? That's it. Every denominator is now a 1. So at this point now we drop the denominators, right? I mean, they're just 1s, so we don't need to write them anymore. And we go through and we say, okay, I got 3 times x plus 1 minus 2x times 2x, so 2x times 2x is equal to, and I'm just going to go -4x times x plus 1. Right, so I got -2 times 2x, let's make that -4x. Here, let's throw that in there. And we solve this, right? So we expand 3x plus 3 minus 4x squared is equal to -4x squared minus 4x. All right, so then I look at that and I say, well, if I add 4x squared to both sides, then that's going to be gone, right? If you have the exact same term on both sides, you just cross them off. Right? It's got to be the exact same. It can't be a -4x squared on one side and a 4x on the other. So we're going to add the 4x to the 3x, giving me 7x is -3, and then say x is -3 over 7. Right? And then we're going to go back and compare that up here and say -3/7 is okay. If I want to verify this, I can just plug it into my calculator, right? Which, if you're doing that on a quiz or test, you do it at the end, right? You can just take -3/7, stick it into a variable like a. So here, I'll show you a verification, right? So here, let's pause. So here's the deal. I think that x is -3/7, right? So I can go -3 divided by 7, enter, right? And I can store that in x, right? So store, that's down here, and it says take the answer and put it into x. So now anytime I use x, so if I went like 2x, right, I get 2 times the x value. So the x value is in there, right? So now I can go and do this. Okay, so let's clear that. So I want 3 divided by 2x. Okay, actually, you know what? Let's put brackets around that. Bracket 2x. That's going to 2x. Okay, minus bracket 2x, bracket divided by bracket x plus 1, x plus 1. Okay, now if that's right, what's going to happen when I hit enter? We're going to see -2, right? It says equals -2. Okay? So way to check. Don't check until you've done the entire test, right? I mean, checking takes time. So, you know, if you're going to hand it in early, I'm going to assume you went back and you checked everything, right? You said, okay, I put the x value in. Right? And that's an easy way to do it, right? Because you could just use the x. You don't have to play around with other variables. The x is very easy to get because it's right here, right? Just hit that key, you get x. Okay, so that's one way. Let me show you an alternate version, okay? Also acceptable, right? So if we're looking at what work do I have to show? You either show this work or, okay, so I can do 3 over 2x minus okay, so same thing. Number 1, factor, okay, it's factored. Number 2, restriction, state the restrictions. Restriction, x cannot equal 0 or -1. The LCD is 2x and x plus 1. All right, now, you think about this. What are we actually doing here, right? The whole idea in solving these equations is to get rid of denominators. So when we set the LCD, we're doing it with the idea that this is going to go away. And this is going to go away. And there's nothing here to go away, but the stuff's going to come in. So I'd say, all right, I know that I need to multiply this by the LCD, which is going to end up being 3 times x plus 1, right? Because the 2x is going to cancel. Minus, and I got a 2x, and what's it going to be multiplied by? Just the 2x, right? Because the x plus 1 is going to cancel. And that's equal to -2, and there's nothing to cancel, so we have to put down the full denominator. Okay, and then after that, it's exactly the same, right? So all we've done is, so if you want to use this, that's fine. Just, you know, be careful, practice, fix it, right? If you make mistakes, fix it. So you see this line here, that's my second line, and over here, it's like my third line, and there's a whole bunch of stuff in here, right? So you don't need to do this stuff. Okay? You don't need to show me that, right? You show me this, you just say, hey, I know the 2x's are going to cancel, so the 3 is going to be multiplied by this. This is going to cancel, so the 2x is multiplied by the 2x. And there's just a 1 there, so I got to write out the whole denominator. Right? So, your choice, right? As far as, if I say determine, and determine means show your work, then that's good enough for showing work. Minus 6 over x. Okay, this time we actually can factor something. So, what factors? X squared minus 3x, right? So we have to show this. You must show this next line. optional stuff, like, you know, if you want to, when you do the cancellation, you don't need to show me the I'm going to multiply every term by this, but you got to show this. Okay, now we state restrictions. What are the restrictions? 0 and 3. Okay, now we're going to multiply. What's the LCD? X times x minus 3. The problem if you don't factor it is all of a sudden your LCD is x times x minus 3 times x squared minus 3x, right? And now your numerator gets really big because all of a sudden now you've got x to the fourths in there and stuff, right? Because you didn't factor and recognize that, oh yeah, there's only really 2 things in the denominator, right? You've got 3 things in the denominator now and you're multiplying, yeah, it just becomes a horrendous mess. It's going to take you a lot of time, right? And you're going to get it wrong in the end. Okay? You will, right? Because it's just way too complicated, right? If I did this using those 4, I would have x to the fourths in there, right? Now, as soon as you see you're writing down your first x to the fourth, that's when you go, oops, I made a mistake. And at that point, you should just stop and go on with other questions on the test, or back up and say, oh wait, I forgot I got to factor this, right? And then pick up. Okay, my next line, I'm going to multiply by the LCD. Do you want the easy way or the hard way? Easy way? Okay, so this becomes what? 12. Minus 6 times what? Is equal to 4 times what? X. Okay, everybody who doesn't see that, don't be afraid. Just here, I'll go face out the window. You can just say, show me the, I won't know who said it. You want to know where that came from? Yeah. All right, good. I don't mind showing. So let's move this down. Okay, so what I'm going to do is I'm going to multiply. How many terms do I have there? There are 3 terms. I'm going to multiply each term by the lowest common denominator. So I'm going to go x times x minus 3 over 1 times 12 over x times x minus 3 minus x times x minus 3 over 1 times 6 over x is equal to 4 over x minus 3 times x minus 3 over 1. Okay? All right, and then what? Well, now I go and I cancel, right? So the x minus 3, the x minus 3. Okay, I got 1, 1, 1, 1, 1, 1, 1. Okay, what's left? Well, I have a 12 minus 6 times x minus 3 is equal to 4 times x. Okay, so we're getting that same expression, right? And, you know, I'm glad you said that because, you know, you may have to do that. That's fine. There's nothing wrong with doing, oops, that's not so good. There's nothing wrong with doing that. Right? There's absolutely nothing. Or don't feel like, oh, you know, I don't. Fine. Right? That's good. You're gonna get it right. Somebody else will do it the easy way. They'll get it wrong. All right. So now solve this. Expand it and solve it. Okay. So expand. Watch your signs when you expand. 12 minus 6x minus 18.
Plus 18.
Yeah, it would be plus 18. Yeah. Yeah. Good. Waiting. Took a while. Figured I'd do that. I didn't have to erase anything, right? If I wrote a plus and it should be a minus, and I got to erase that. But yeah, watch your signs, right? Minus 6x plus 18. All right, what do we got here? Let's move that over. So we're going to end up with 30 is equal to 10x, and x is equal to 3. Okay, we put a box around it, and we wrap it up, and apply a little bow. Oh, but wait. See, I didn't see because it was off the page. We said that x cannot equal 3. Okay, so what are we going to say? No solution. No solution. So if you went and graphed this thing, graphed like the left side and the right side and looked for the intersection, there wouldn't be one. Okay, there would be no solution. if you went and graphed this thing and moved this over so it was minus 4 over x minus 3, it would not ever equal 0, right? Because that would have to equal 0. Okay, so there is no solution, right? So you should still show, hey, look, I'm solving it, and here's my solution, and oh, wait, restriction, you can't do that. Okay, question. All right, so your choice as to whether or not you want to show this line. I don't care. If this is wrong, I care, right? I mean, you know, it's like, if you do this and this is wrong, you will lose fewer marks than if you don't do this and this is wrong, right? So if you do this and this is wrong, I'll kind of look and say, oh, you see that? Yeah, that should have been a this, and I get a half mark off. And if you just go to here, and it's like, yeah, you're losing a full mark. Right? I mean, you chose not to do that, which is fine. It's a valid choice, but you maybe don't have the skill set that allows that, right? So you have to know yourself, know your skill set. Okay, one more. 3x over x plus 2. Minus 5 over x minus 4. Equals, wait for it, 4x squared minus 15x minus 18 over x squared minus 2x minus 8. All right, what's your first step? What do you have to do? Factor the denominator, right? Which we already know what it factors as, right? It's obviously x minus 4 times x plus 2. Because if it is, then life's going to be pretty easy when we go to solve this, right? And if it's not, then it's going to be more difficult. And we don't make life that difficult for you. However, you should still actually factor it. So 3x over x plus 2 minus 5 over x minus 4 is equal to, do not touch the numerator. X squared, oh, wrong signs. X minus 4. Okay, this is likely what's going to happen, right? These guys are the same as those guys. It makes life a lot easier when you go to simplify it, right? Okay, next step. Restrictions. Restrictions. Right? We need those, right? Like, we really need those now, because if we go and solve this thing and we say, hey, x is 4, then we have to say, no, it's not. It can't be, right? That's a restriction. Okay, so do the next line, like, or lines, right? So you can do this in one line or 2 lines. So write down, get to the point where you've got 3x times something minus 5 times something is equal to something.
Sounded very intense.
Okay, so either 1 or 2 lines, you're now sitting here, yeah? And I didn't try and make any mistakes here, so I think this is right. If it's not, you should let me know. Okay, so now we want to solve this. So we got to expand, right? So we get 3x squared minus 12x minus 5x minus 10. Yeah, I mean, I wasn't actually trying. I was trying to be right this time. Yeah, okay, minus 10. 3x squared minus 17x. Okay, how are we going to solve this? Quadratic goes back to like the second unit, right? What do we do to solve this? Set it equal to 0, right? So we're going to move, now I'm just going to move the 3x squared to the right-hand side, right? So 4x squared minus 3x squared, because I really want to have a positive 1x squared, right? So I don't want to do this. Oh, let's subtract that. No, let's subtract that. So what are we going to get? X squared. And I'm going to add 17x plus 2x. And I'm going to add 10 minus 8. And that's going to be equal to 0. So I moved everything over to the right-hand side, making the left-hand side 0, and then I swapped the sides so that the left-hand side became the expression. Now this should factor, right? And I get x is equal to 2 or negative 4. Now, I got to go look up the page, because for me, so negative 2 and 4, 2 and negative. Okay, so we're good, right? I mean, they're the same numbers, but they have opposite signs, so they're good. X can be 2 and x can be 4. Okay, so if you put a 2 in here, you're going to get 6 over 4. I mean, these should be equal. Right? Like, I'm not going to do it. There's way too much stuff to do putting a 2 in there. Okay, you could graph this. You could solve this graphically, right? You do this is y1 and this is y2, and then look for the points of intersection. Really handy if you have the color calculator, because because without the color, you're going to have lines crossing lines all over the place, right? It's going to be, yeah, it's still doable, right? And the thing is, you shouldn't generally be solving this graphically before you do it algebraically. You should be doing this algebraically and then saying, yeah, okay. So that I could check this by graphing that and then saying, oh yeah, right, x is 2 and x is negative 4. That's where these guys meet, right? Okay. And we don't care about the y values, right? We are solving for x. So the solution is not a point. The solution is a value of x that makes this true. Right? That's another thing where you're kind of mixing concepts, right? It's like, well, but 2 days ago the solution was a point, and now the solution is just a number. Okay, and you have to know, when is the solution a point? When is the solution a number? Here it's just a number, right? What value of x makes this true? Okay, I mean, if I graph it, now I'm getting y values. I don't care about the y values. What value of x makes this true? As opposed to, where's the point of intersection of, this quadratic and this linear, right? Those solutions are not the x values. They're this point and this point, right? That's solving a system, though. All right, that's all I got for you. Okay, so you have the worksheet that's referenced is really just full of questions, and there's also textbook questions, and then tomorrow will be a further work period on that. Okay, so you've got a couple of days, and you really need to do these, right? You really need to solve a bunch. And then kind of this weekend, because the test is Tuesday, this weekend you got to go back and just go back and do some simplifying, some multiplying and dividing, right? So you get it straight. So on the test, you're not sitting there saying, is this one where I do the LCDs? Or is this one where I factor the numerators? Or do I not factor the numerators? Right? So you have to know this, right? Is this one where I'm solving? Should I get a value of x or not get a value of x?